With this section, we're going to be looking at function inequalities, essentially, like which function is bigger than the other function over different ranges. Consider the following graph functions. Fill in the blank comparing the functions with an inequality symbol. Alright, so they want us to compare f of x to g of x, right? There's f of x and g of x. And g of x is always above f of x, and so that means g of x should always be greater. So on this one, all they want us to do is simply write that is greater. Alright, same thing on this one. H of x is always above k of x, even though it's down here lower. If you went far enough down, this would continue to stay underneath that line, because this line is always going to be above the parabola. The parabola is moving down faster and faster. So in this case, since h of x is always above k of x, we just have to draw an inequality showing that h of x is larger. Alright, now we have a little more complicated. The functions are kind of overlapping, and they want to know for which values of f of x, for which values of x is f of x greater than g of x. Alright, so in other words, we want to know when the blue line, the blue graph is on top. So here it's below the green if you look right in this region, but in this little section right here, the blue is above, it's on top of the green. So from -1, let me show you where I got that from. Let me kind of line this up. From -1 to 2, it's above. So this whole region right here is above, and you describe that region where it's above based on the x values. So we can either write this in interval notation, which is pretty straightforward. You're just saying from left to right that the blue function is higher than the green function from -1 to 2. And so you say from -1 to 2. In set notation, that would look a little different. It would be -1 is less than x, which is less than 2. You're saying it's between, from -1 to 2, the blue is on top of the green. Alright, try again on this one. You may want to pause. Where's the blue above or on top of the green? And it looks like, if you looked from right here, the blue starts to be on top right there at 1, and it's still on top all the way up till 4. So this region right in here, the blue line is above the green. It's on top of it. So for interval notation again, from left to right, we'd say from 1 to 4. And if we want to say that same thing in set notation, we'd say 1 is less than x, which is less than 4. They say the same thing, it's just two different ways of saying it. And this last one's a little more complicated. When is the blue function above the green function? Alright, so the blue function f of x is higher over here and over here. It's got two regions. The green is higher in the middle, but on the left and on the right, the function f of x is higher. So where does that happen? It looks like it happens at 0, and the other point where they intersect is 2. So basically from -infinity all the way up to that 0, the blue function is above the green function, and also from 2 to positive infinity. Alright, so in interval notation, we would write that as -infinity to 0, and the way I did that is because that's where they meet. And then it's also, so union, I draw a little u, it picks up on the other side. The blue function is above. I know it's kind of hard to look at this, but you got to look at this in terms of left to right. If you covered up this whole region right here and just looked at the blue here and the green down here, the blue's above the green to the right of 2. So to the right of 2 would mean basically everything from 2 to positive infinity. So to the right of that dot where they intersect, the blue is above the green because the green is way down here. In set notation, you'd have to write that in two statements. You'd have to say that x is less than 0, that's pointing to the left, and you'd write or x is greater than 2. Alright, for these next ones, I think it'd probably be easiest if we graphed each one to look at. It says, write an inequality statement for all x of which function is greater. Alright, well, let's use our calculator to compare those two. So if I typed in this first one, it says -x squared minus 3. Oop, I should have cleared first. -x squared minus 3. And then 1/2, 1 divided by 2 in parentheses, x plus 2. So it looks like we'll have a parabola and a line. So let's see, and then we hit graph. And they want to know which one's always on top. Okay, I think it's pretty clear on this, the line's always on top. So in this case, g of x is always bigger. So if we trace this in the colors, g of x is the line, which is this one right here, and f of x is this parabola right here. So the green one is bigger, so we need the alligator to open towards the g, eating the g, so it's bigger. Alright, let's try the next one. Again, we need to graph both of them. So let me go to y equals and clear out the old graphs. Alright, this first one says 3 raised up to the x plus 2 compared with 1/2 in parentheses x minus 2. There's the exponential, and there's the line, and you can see the exponential is always above the line in this case. So if I color code these, I guess the best I can, it looks like p of x is the exponential. Would be this one right here. And the line would be the 1/2 x. And so since the dark purple p of x is always bigger, it's on top, we draw the inequality this way. So the alligator eats p of x because it's bigger.